Question number 21. A large water tank stands on a frictionless surface. The seal over a circular hole of radius 0.5 centimeter in the wall of the tank ruptures. If the level of the water above the hole is 1 meter, then the force that must be applied on the cylinder to keep it from being set in motion is 6.16 Newton, 3.08 Newtons, 1.54 Newtons and 0.77 Newtons. So here we will draw the problem as is. If this is the tank and this is the tank is kept on a frictionless surface. Now if you made a hole, then the liquid is coming like this. Then to what height is liquid is there? It is a height of 1 meter water is there. So when it is coming out, so if water is coming out like this, so there is a reaction acting on this one. So when the reaction is there, this may slide in this direction. So the entire tank slides in the opposite direction. So what should be the applied? What should be the force that should be applied here to make it a stationary? So we have to calculate the reaction force. Sorry, okay. Now for that we will first calculate the velocity with which water is coming out. So that we call as velocity of efflux. So velocity of efflux V is equal to 2gh. In this case h is 1 meter. So V is equal to root 2g. Now amount of mass of the water flowing out per second. So mass of the water flowing out per second, mass flows out per second, m by t we can say is going to be area of cross section into velocity into rho. Now here area of cross section is pi r square. Now since we are calculating these two quantities, velocity of a flux and mass going out per second, now we can calculate the force. Force is equal to mass into acceleration. So because force is equal to mass into acceleration, or we can say m into it is v by t, or m by t into v. That is what is m by t? So what is m by t now? M by t is a v rho. So it is a v rho into what is v is given as root of 2g. So mv rho into v we need here. So we will calculate now. So the force of which pulling the body away from that, or the force which reaction force on this is a v square rho. A is already I have told it is pi r square. So pi r square v square rho. So we now calculate F is equal to pi. It is a 3.14. R is given as a 0.5 centimeters. So 0.5 into 10 power minus 2 the whole square into V is a square root of root g. So V square is a 2 into g, 9.8 into rho is a 10 power 3 . So now we can go for the calculation now. So everything we have substituted, just we have to calculate. So F is equal to, so 3.14 into 0.5. So it is 3.14 into 0.25 into 2 into 9.8 into, here it is 10 power 3, here there will be a 10 power minus 4. So it's going to be 10 power minus 1. So it is simply 50 15.38 into 10 power minus 1. So it is going to be 1.54 Newton is the reaction force acting on the tank. So 1.54 of Newton you have to apply to keep it stationary. So the correct answer is C, 1.54 Newtons.